In this lesson, we're going to focus on graphing more advanced rational functions. So let's start with this example. X plus 2 divided by x squared minus x minus 6. So what do you think we need to do here in order to graph this function? Well, first, we can identify the horizontal asymptote. As in the previous lesson, we know that whenever we have a rational function that's bottom heavy, meaning that the degree of the denominator is greater than that of the numerator, the horizontal asymptote is simply y is equal to 0. Now, in order to find the vertical asymptote, we need to factor. Two numbers that multiply to negative 6 but add to negative 1 are negative 3 and positive 2. So this can be factored as x plus 2 times x plus 2 x minus 3. So notice that we can cancel x plus 2. So the term x plus 2 will give us the whole. If you set x plus 2 equal to 0, x is equal to negative 2. So we have a whole at negative 2. Now we need to find the y value of the whole. To do that, plug it into the surviving equation. The surviving equation is 1 over x minus 3. This is the one that we want to graph. If you plug in negative 2, it's going to be 1 over negative 2 minus 3, which is 1 over negative 5. Now, the next thing we need to find is the vertical asymptote. So we can find that by setting the denominator equal to 0. So the whole is not going to be the vertical asymptote. It's going to be this factor. So we need to set x minus 3 equal to 0 because it doesn't cancels. So the vertical asymptote is x is equal to 3. Now this is enough information in order to graph it. So let's get rid of this stuff. And now let's make the graph. So let's plot the vertical asymptote, which is x equals 3. And now let's plot the horizontal asymptote, which is y equals 0. That's the x-axis. Next, let's plot the whole, which is at negative 2, negative 1/5. Negative 1/5 is like negative 0.2, so it's very close to the x-axis. Let's say it's over there. Now the surviving equation is 1 over x minus 3, which is similar to 1 over x. And we know 1 over x looks like this. So 1 over x minus 3 will have the same general shape. If you want to find another point, we can also find the y-intercept. What is the y-intercept of this function? To find a y-intercept, replace x with 0. So if we plug in 0, this is going to be negative 1 over 3. So this is like the y-intercept. Now let's graph it. Now we need to find the domain and a range. How can we do that? So for the domain, we know that the lowest x value is negative infinity and the highest is infinity. However, x cannot equal the vertical asymptote, which is 3, nor can it be equal to the whole because the whole doesn't exist. It's a point of discontinuity. And the whole has an x value of negative 2. So keep this in mind. When writing the domain in interval notation, remove the x coordinate of the whole and the vertical asymptote. So the domain is going to be negative infinity to negative 2. So just write everything from left to right in that order. So negative infinity to negative 2, and then union negative 2 to 3, union 3 to infinity. So that is going to be the domain. Next, let's find a range. The lowest y value is negative infinity and the highest is infinity. Now we need to remove the y coordinate of the whole, which is negative 1/5, and we also need to remove the horizontal asymptote, which is 0. So writing it in increasing order from the top to the bottom, the range is going to be, first I'm going to need to make some space, so let's get rid of that. So it's going to be negative infinity to negative 1/5 union negative 1/5 to 0 union 0 to infinity. So whenever you're writing the range in interval notation, remove the y-coordinate of the whole and the horizontal asymptote. Let's try this. Let's say that y is equal to x squared minus x minus 2 divided by x squared minus 2x minus 3. So feel free to pause the video and work on this example. Now the first thing we should do is factor completely. So what are two numbers that multiply to negative 2 but add to negative 1? This is going to be negative 2 and plus 1. Now what about two numbers that multiply to negative 3 but add to negative 2? So this is going to be negative 3 and plus 1. Negative 3 times 1 is negative 3, but negative 3 plus 1 is negative 2. So we can see that x plus 1 is associated with the whole. If you set x plus 1 equal to 0, x will be equal to negative 1. So that's the x-coordinate of the whole. We could find the y-coordinate later. Now, in the surviving equation, which is x minus 2 over x minus 3, we can see that the vertical asymptote is going to be x equals 3. And you could find it by setting x minus 3 equals to 0. If you add 3 to both sides, you'll see that x is 3. Now what about the horizontal asymptote? Notice that the degree of the numerator is the same as that of the denominator. So you got to divide the coefficients. 1 divided by 1 is 1. So the horizontal asymptote is simply y equals 1. Now let's find the y value of the whole. Let's replace x with negative 1. So it's going to be negative 1 minus 2 over negative 1 minus 3. So that's negative 3 over negative 4, which is positive 3 over 4, which is about 0.75. Now what else can we do? Sometimes it might be useful to find the x and the y-intercept. To find the y-intercept, replace x with 0. So this is going to be negative 2 over negative 3, which is positive 2 over 3. So the y-intercept, as an ordered pair, is 0, 2 over 3. Now let's find the x-intercept. To do that, replace y with 0 and solve. So let's multiply both sides by x minus 3. So these two terms will cancel. 0 times x minus 3 is 0. Now let's add 2 to both sides. If we do that, x is equal to 2. So the x-intercept is 2, 0. Sometimes you might have a test and you might receive directions to find the x and y-intercept. So that's why we need to do that here. So let's go ahead and graph the function. So we have a vertical asymptote at x equals 3. And we have a horizontal asymptote at y equals 1. And we have the point 0, 2 over 3, which is here. That's the y-intercept. And also 2, 0. And we have a hole at negative 1, 3/4. So we can see that the graph is going to look something like this. Now what about the right side? Chances are the graph is going to be in this region. But to find out for certain, we can plug in a number. The vertical asymptote has an x value of 3. So let's plug in a number greater than 3. Let's try 4 using this equation. If you use this one, you'll get the same answer because these two cancel. So let's replace x with 4. 4 minus 2 is 2, 4 minus 3 is 1. So when x is 4, y is 2. 2 over 1 is 2. So let's plot that point. 4, 2 is here. So we know that it's going to be in the upper right corner. So now that we have the graph, let's go ahead and find the domain and the range. So let's start with the domain. The lowest x value is negative infinity and the highest is infinity. We need to take out the x coordinate of the whole, which is negative 1, and we need to remove the vertical asymptote, which is 3. So the domain is going to be negative infinity to negative 1 union negative 1 to the vertical asymptote, which is 3, and then union 3 to infinity. And now for the range, the lowest y value is negative infinity and the highest is positive infinity. We need to take out the y coordinate of the whole, which is, we said it was 3/4, and we need to take out the horizontal asymptote, which is 1, in increase in order. So the range is going to be negative infinity to 3 over 4, union 3 over 4 to 1. 1 comes after 3 over 4. 3 over 4 is 0.75. And then union 1 to infinity. So that's the range. Here's the next example. 1 over x squared minus 4 plus 2. So feel free to try this problem. Let's begin by factoring x squared minus 4. It's a perfect square. We can use the difference of perfect squares technique. The square root of x squared is x, and the square root of 4 is 2. So it's going to be x plus 2 and x minus 2. So there's no holes. We can't cancel x plus 2 or x minus 2. So both of these will represent vertical asymptotes. If you set x plus 2 equal to 0, x will equal negative 2. And if you set the other one, x minus 2 equal to 0, x will equal positive 2. So those are the two vertical asymptotes. Now, do we have any horizontal asymptotes? Well, we do have a function that is bottom heavy, and anytime it's bottom heavy, the horizontal asymptote is 0. The degree of the denominator is higher than that of the numerator. So this portion is 0, but we've added 2 to it. So the horizontal asymptote is going to be 0 plus 2, which is 2. So it's y is equal to 2. Now, let's find the y-intercept. Let's plug in 0. So it's 0 squared minus 4 plus 2. So that's negative 1/4 plus 2. 2 is the same as 8 over 4. Negative 1 plus 8 is 7. So we get 7 over 4. So that's going to be the y-intercept. So it's 0, 7 over 4. 7 over 4 is about 1.75. Next, let's find the x-intercept. So let's replace y with 0. And now let's subtract both sides by 2. So if we move the 2 to the other side, it's going to be negative 2. And then we can write it as negative 2 over 1 and then cross multiply. 1 times 1 is 1. And negative 2 times x squared minus 4, that's going to be negative 2x squared plus 8. So now let's subtract both sides by 8. This is going to be negative 7. And then if we divide both sides by negative 2, x squared is equal to 7 over 2. 7 over 2 is about 3.5. And if we take the square root of both sides, x is going to be plus or minus the square root of 3.5. By the way, for those of you who want the exact value, root 7 over 2 is root 7 divided by root 2. You need to rationalize. If you multiply the top and the bottom by the square root of 2, this is going to be the square root of 14 over the square root of 4, which is root 2. Just 2. So you can say the x-intercepts is plus or minus root 14 over 2, comma 0. but I'm going to write it like this. I'm going to use 1.871 because I need to graph it. So now that we have enough information to make a decent sketch of our graph, let's go ahead and do that. So first, let's begin by plotting the horizontal and the vertical asymptote. So we have a vertical asymptote at x equals 2, and also another one at x equals negative 2. The horizontal asymptote is at y equals 2. So here it is. Now we have the points 0, 7/4, the y-intercept. 7/4 is 1.75. So it's just below the horizontal asymptote. And we have an x-intercept at negative 1.871 and positive 1.871. So in the middle, we can see that the graph is going to look like this. Now what about the left side and the right side? On the right side, it can be like this, or it can be like that. On the left side, it's one of those two. All we need to do is plug in a point to see if it's above or below the horizontal asymptote. So we need to plug in a point to the left of negative 2 and one to the right of positive 2. So let's try 3. And let's use the first form of the equation. So 1/3 squared minus 4 plus 2. 3 squared is 9. 9 minus 4 is 5. So it's going to be 1/5 plus 2. 1/5 is about 0.2. So it's about 2.2. So we have the point 3 comma 2.2. So at 3, it's going to be just above the horizontal asymptote, which means that the graph should be in this region. Now, if we plug in negative 3, negative 3 squared and positive 3 squared, they both equal 9. So if you plug in negative 3 into this equation, you're going to get the same answer. It's going to be negative 3 comma positive 2.2, which means that the function is even. It's even with respect to the two vertical asymptotes, and I missed it again. Here we go. So that's the graph of this particular function. That's how it looks like. Now the last thing that we need to do is determine the domain and the range. So let's start with the domain. The lowest x value is negative infinity, the highest is infinity, and we need to take out the vertical asymptotes. There's no hole in this graph, so we don't have to worry about that. So the domain is going to be negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. And now for the range. The lowest y value is negative infinity, the highest is infinity, and we need to remove the horizontal asymptote, which is 2. So the range is going to be negative infinity to 2, union 2 to infinity. And that's it. Here's the last example. Y is equal to x squared minus x minus 2 over x minus 3. So what should we do in this problem? Feel free to pause the video. Do we have a horizontal asymptote? Notice that the degree of the numerator is greater than that of the denominator, so there is no horizontal asymptote. However, because the degree of the numerator exceeds the denominator by exactly 1, there is a slant asymptote. So let's go ahead and find it. And to do that, we need to use long division. So let's divide x squared by x, which is equal to x. Next, let's multiply. X times x is x squared. X times negative 3 is negative 3x. And then subtract. X squared minus x squared, that is 0. And then negative x minus negative 3x, that's negative x plus 3x, which is positive 2x. And then negative 2 minus nothing, we could just bring down the negative 2. And let's divide again. 2x divided by x is positive 2. And now let's multiply. 2 times x is 2x. 2 times negative 3 is negative 6. 2x minus 2x is 0. Negative 2 minus negative 6, or negative 2 plus 6, is 4. So the remainder is 4. But this is going to be the slant asymptote. So the slant asymptote SA is a function. Its y is equal to x plus 2. Now let's go ahead and factor the original function. What two numbers multiply to negative 2 but add to negative 1? So that's going to be negative 2 plus 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So there are no holes in this graph. None of the factors cancel. However, we can find the vertical asymptote if we set x minus 3 equal to 0, in which case x will be equal to 3. Now, what are the x-intercepts? In order to find the x-intercept, set y equal to 0. And then let's multiply both sides by x minus 3. Those two will cancel. 0 times x minus 3 is 0. So 0 is equal to the numerator, which is x minus 2 and x plus 1. So we could set 0 equal to x minus 2, because if this is equal to 0, 0 times x plus 1 is 0. And we can set the other factor equal to 0. So therefore 2 is equal to x, and x is equal to negative 1. So those are the x-intercepts. We have the point 2, 0, and negative 1, 0. So x is 2, and y is 0. Now let's find a y-intercept. Let's plug in 0 into the function. So this is going to be negative 2 over negative 3. So the y-intercept is 0, positive 2 over 3. The two negative signs will cancel. So now we have enough information to draw a nice graph. So let's start with the vertical asymptote, which is x equals 3. Now let's plot the slant asymptote. So notice that the y-intercept is 2, and the slope is the number in front of x, which is, if you don't see a number, it's 1. But let me just add some marks to the graph. So the y-intercept is 2, and the slope is 1, which means that the rise is 1 and the run is 1. So the next point is going to be 1, 3, and then 2, 4, and then 3, 5, and so forth. If we go backwards, negative 1, 1, negative 2, 0, negative 3, negative 1, and so forth. Now there's 4 regions where the graph can locate, or be located rather. It can be in this region, or it can be in this region, which I don't have enough space to plot there, or it can be in this region, or this one. So I might need to expand the space. So what I'm going to do is I'm going to regraph it. So let's put some marks. So let's graph the vertical asymptote, which is at x equals 3. And then the slant asymptote, which has a y-intercept of 2 and a slope of 1. So we can see the graph looks something like this. So now we have more space in this region. Now let's plot the points that we have. So we have an x-intercept at 2, 0, and another one at negative 1, 0, which is here. And the y-intercept is 0, 2 over 3, which is just under 1. So somewhere in this region. So the graph is going to follow the intercepts. So it should look something like this. And that's just a rough sketch, but it has to pass through those points. I mean, it could be like this, could be like that, we don't know, but this is acceptable. Now, on the right side, that is to the right of the x-intercept of 3, the vertical asymptote of 3, we need to know if the graph is going to be here or if it's going to be in this region. So what we can do is plug in an x value that is greater than 3. Let's try 4. And let's use this equation. So it's 4 minus 2 times 4 plus 1 over 4 minus 3. 4 minus 2 is 2, 4 plus 1 is 5, and 4 minus 3 is 1. So 2 times 5 is 10. So we're going to have the point 4, 10. And if we plot it, that should be somewhere over here. Now let's get another point. Let's try 5. So 5 minus 2 is 3, 5 plus 1 is 6, and 5 minus 3 is 2. So 3 times 6 is 18, divided by 2, that's 9. So we have the point 5, 9. And let's get 6. 6 minus 2 is 4, 6 plus 1 is 7, and 6 minus 3 is 3. So it's 28 divided by 3, which is about 9.3. So at 6, it's going back up, but only a little. So we could say that this graph looks something like this. And so that's it for this problem. Now there is one more thing that we do need to mention, and that is the domain and a range. But we have to be careful with the way we calculate it. So let's start with the domain. The lowest x value is negative infinity. This blue curve will keep going towards the left. The highest x value is positive infinity. And x cannot equal 3, the vertical asymptote. So it's easy to see what the domain is going to be. Negative infinity to 3, union 3 to infinity. Now the range is a little bit more trickier. We can see that the lowest y value is negative infinity and the highest is infinity. However, we need to know the maximum y value here and the maximum y value there. We don't have the techniques to figure this out based on the things that we've learned in algebra. Maybe you could find it using calculus. The only other option to find the maximum y value and the minimum y value is to use a graphing calculator. So I don't have a graphing calculator with me. Let's just estimate it. Let's say this is 1.5. Keep in mind it may be 1.6, it may be 1.43, but let's assume it's 1.5. Let's say you use a graphing calculator and you find out the highest y value in that region. And let's assume the lowest y value is 9. This is how you need to write the range. The range is going to be negative infinity to 1.5, union, and then you start back at 9 because there's nothing between 1.5 and 9. It's empty. So 9 to infinity, that's going to be the answer. Now keep in mind, it may not be exactly 1.5 or 9, but it's going to be close to it. So you can use the graphing calculator to find out the exact values of these. So that's simply an estimate.